Hello guys, and welcome to a new video from my YouTube channel, and here is Sha'an Al-Shayah. If it's your first time to watch a video in this channel, please subscribe and enable the notifications to stay updated. As you can see from my screen, you can now reach out to me using Facebook and Instagram besides to YouTube, and currently you can even donate to support my channel, which will help me keep going and make more videos about this topic. So please make sure to follow me as well on Facebook and Instagram, and I hope to hear from you. As you might know already, I am trying in this channel to cover two main topics, which is the first one, the AI topic with deep learning and PyTorch tutorial, and the second one is mainly my main topic now, is covering life in Germany. So also, if you are interested, just keep following me, and I will also even provide subtitles for the Arabic videos. But mainly for this video now, we are now interested in the PyTorch tutorial, and this video is actually a part of a video series that will cover building an image classifier using PyTorch from the very beginning till testing. And as you can see from my screen, these are the videos that I have covered so far. And in the last video, we have used together transfer learning with ResNet 18, and I have shown you how we can modify the last layer in ResNet 18 in order to make it fit to our new topic with the classifier we are building. And as promised, I wanted to give you another example with Vgg16, and this is what we are going to do today. So back to my Google Drive, where I show you always the files that I'm using. In this video, we are using today the Vgg16 PyTorch classifier notebook. And you don't have to worry about this. I will also share this on my GitHub, and you will have the link in the description. So what I'm going to do is just to go into this notebook, and I'm going to start over with you. So since we learned from the last video that the first thing we have to do is to change the runtime to the GPU, so I'm going to go to runtime and then go to change runtime type, and instead of using none, I want to use GPU, and then you click save. Now we have the GPU activated. So what I'm going to do is, just as usual, I will run all the cells. You can see the common thing that will happen even with you is that you might not get the pillow version that you wanted, which is for us was 5.3. So I'm going to restart the runtime by going to runtime and clicking on restart runtime, and then yes. And after this is done initializing, like now, we can rerun the cell and hope that we get the correct version. So now, since we have the correct version, I will just run the cells and make it fast for you so you don't have to wait. So now we are at the step where we use the Vgg16 pre-trained model, and when I say pre-trained, I mean that I set the pre-trained attribute to true. And you can see that it has downloaded the model, and you can even have a look on how much megabytes it has used and from where it came from PyTorch. But what we want to see is actually the model structure itself. So if I just print the model, you can see, like what we just did with ResNet 18, you can see all the layers in VGG, and you can even scroll down, which is the interesting part for us, where you find the last layer, which is the classifier layer. And you can see at the end of the classifier layer, we have a linear layer with certain input and 1000 output features, which are the classes from ImageNet which have been used to train the Vgg16 model. And now what we want to do is to make this suitable for our own case, which is the 102 classes of flowers. And in order to do this, I have two ways. I either change the last linear layer of the classifier layer, which is the first way that I will show you, and the second way is to remove the whole classifier layer and build a new one. The most important thing is to make the output features fit to your problem. So as I said again, for our use case we have 102 classes, so what we care about is eventually whether we just change this linear layer or if we change the whole classifier layer. The main point is to have 102 output features at the end. That being said, let's check out the first way, which is basically to keep the classifier layer as it was, with the sequential layer which has the first linear layer and the second linear layer, and what we are going to change is just the last linear layer. And specifically what we want to change is this 1000 to 102. So what I'm going to do is to use NN linear and have the same input as it was, which was 4096, and I'm going to have an output of 102. And I will put this linear layer into a variable which I call, it's up to you what you call it, I will call it here the last layer. Now I want to put this last layer as a replacement for the classifier layer number 6. And in order to get to this layer of my model, I will call my model, actually you don't have to call Vgg16, this is a typo. So if you are not using the model name or you are keeping the Vgg16 name, then you just can have Vgg16. But for my case, I put the model Vgg16 into the variable name model. So what I'm going to do is actually to use this model I have and have the dot operator to enter the classifier layer. So in order to get to the layer number 6, I just put this 6 number into the square brackets. And I use this last layer as a replacement for the previous one. So if you run now this cell and you eventually even print the model, you will see the new replacement of the last one. I will scroll down now and we are supposed to see the last linear layer with the same input and output of 102. And this is what we expected. That was the first way, and as you have seen, it's really straightforward. You just remove the 1000 and replace it by the number of your classes. Now I am going to show you the second way, which is really replacing the whole classifier layer and using the thing that you want. So let's say I have my model and I just get to the classifier and I remove this. Now, as you remember from the first way, we had classifier. I also had number 6 into the square brackets. So for us, in order to get to the whole layer of the classifier, I just replace it by model.classifier, and now I put whatever I want, which is in this case the simplest way of having NN linear. And what you might notice is that here I have a different number. It's no longer 4096. I have the first number, which is exactly what I want, because I want to replace the whole classifier. So what I'm going to use is basically the output of the previous layers. And here usually you have to calculate it by yourself because it's an output of the convolutional layer, and usually in order to avoid calculation you just use what has been used before. So now I have 25,088 and I'm just going to use this number and whatever number of classes you had. The problem with this is that we are jumping really from 25,000 features to 102 features, and this is why usually people don't do this. They don't replace a whole classifier layer to one simple linear layer. You will do more complicated things. And for that I have another example here by being more creative. We will check this out after I finish this one. But for this case, it's still alright. You can even do this, but it's just a way to show you that I can even replace the whole layer. If you remember from the ResNet 18 example, we had, instead of model.classifier, we had model.fc, which is fully connected. And this is really just a name that is used inside the structure, and you can just check it out from the name that you have in the model structure that you can see when you run the cell. So now we want to see the output of this and make a comparison with the difference. So I will run this cell, But of course you still cannot see anything because I did not print the model. So I print the model here and I run the cell, and you can see now the new structure of Vgg after replacing the last layer. So before, in the first way, we just replaced the last linear layer of the classifier. Now what we will see is that we have removed the full classifier layer and made it in this way. So it's now 25,088 and the output is 102. Believe me, it will work. Everything is fine. What you are doing here is just that you are missing out a lot of features in between. So what usually you do is really to gradually jump from something to another thing until you get to your number of classes. So that was the second way. You can of course replace the whole classifier layer with more than one linear layer, which is the usual case, by adding, like, let's say 2 linear layers or 3 linear layers or even convolutional layers. But this is up to you and how much creative you want to be. And of course the training time might be even longer. It depends on what you are using and what combinations you have. But in order also to show you this, how you can do it, I will just do a simple example of using 2 linear layers instead of 1. And you can of course do this to the last layer, which is number 6 of the classifier, or to replace the full classifier layer. It's up to you, but I'm going to do it here on the last on the layer number 6 of the classifier. But of course you can just do it this way, and then you have removed the full classifier layer, which is at the end. So it's up to you. Let's just do it this way since it's available. And what is in here is that you can use something from PyTorch, which is called NN sequential, in which you can cascade a lot of linear layers or any kind of layers you have. So in my case, I'm going to use 2 linear layers and put in between an activation function and a dropout. You really don't have to do this, but usually this is the common practices that you have to do. Whenever you add a new layer or something, you add in between an activation function to make sure that everything you have is still positive. And also you add a dropout. This is also a concept that comes from the theory to make the neural network more generalized. We don't care about these 2 parts at the moment, but as I said, this is a common practice you do. And what we want to take care of is this here. So whatever input I have, actually since I changed the classifier 6 to classifier only, I have to change this number to 5088. And if you remember why, it's because this is the full input. This is the input to the classifier layer. If I am using classifier 6, this should be the input to the last layer in the classifier, which is what it was before, 4096. I hope it's not very confusing now, but if you try it out yourself, you will know the difference. And if you get an error, you will know how to fix it from the error type. So let's do it this way, and I will show you also how to correct the error in case you have it and how to deal with this. But for now, let's continue. So instead of jumping directly to my classes, which is 102, I have an intermediate value, which is 256. Now, what kind of intermediate values you check, it's up to you. You can even choose, for example, 512. But then you have to change also the other layer, which is here, because the output from the first linear layer is an input to the second linear layer. And now I can run this cell, and I will also show you the model, how it will look like. And we run the cell now. You will see that the Vgg16 is now having a classifier of 2 layers, of 2 linear layers, and in between of them there is a reload and a dropout. And this is exactly what we wanted to do. Now let's say I want to have the other example, which was maybe complicated when I said it. Now I will have this 6 and I will run this. You will see that I will get an error that index 6 is out of range. And this error is coming because we have removed this whole classifier layer. So in order to get to the original model and change on that, I will just go up and get the Vgg16 again, just to show you. It's really not complicated, but I want to run this in order to have the model again to the original one, and then I'm going to replace. So I'm going now down again to my example, and now I have the linear number 6 and I can change on it, but I will have to replace the 25,088 by this number here, which is from the last layer, as an input to it. If you don't change this number, you might now not get an error, but when you do the training, you will definitely get an error. And then when you have the error in the training, you will realize that the error is coming from here because it doesn't match with the previous layer. So make sure the input to this new layer is matching the output of the last layer. And then I have an intermediate value of 512 to 512, and now I can run the cell and you can see the new model. I have Vgg16, and at the end I will have the old classifier layer with 0, 1, 2 till 6, and in the layer number 6 I have the sequential model, which I have shown to you just right now. So this was the two ways, and how you can also even make it more complicated. It's up to you and to your data how you build your model or modify the pre-trained models. I hope this was helpful and that you have learned new things. In case you are new to this PyTorch tutorial, please subscribe and don't forget to like and share this video. Thank you for watching and hope to see you in the next time.